Section 1.3 is about linear functions and mathematical models. Let's first define what we mean by function. A function is a rule that assigns to each value of x one and only one value of y. So, for example, f of x equals x plus 2. This is a function. This is a rule of the function. And as you can see, if we plug x equals 1, then we get a corresponding value, that is f of 1 equals 1 plus 2. I mean, I plugged x equals 1 here, okay? So we get 1 plus 2, and that's equal to 3. So the number 1, the input 1, give us the output 3. So this is input, and this is output. The outputs are the corresponding values of x, and sometimes we use y to denote those outcomes, and they are called range of the function. So the function has some values, or has a domain, or the place, or the set from where we get these inputs. So let's call this set x. So we have, for example, 1 here, and we have another set, the corresponding set y, and that is the set of the outputs, and x is the inputs. So 1 is related to 3. So the image of 1 is 3 under the function f. So if we plug f into the plug 1, x equals 1 into the function f, we get 3. So the rule says that you take a value and you add 2 to that value to get the corresponding value from y, from the range. So here we have domain, the inputs represent the domain, and the outputs are the range of the function. If we try another value, for example 6 or negative 6, if we plug negative 6 here plus 2, that gives us negative 4. So for each value from the set x, we have exactly one value that corresponds to this value. So this is a function, or you can think of the function as a machine, where we have the function here. For example, this is an example of a function. Functions can vary hugely. So, for example, f of x equals x plus 2 is a function, and imagine that you have a machine. The function is a machine where we add some inputs here. For example, x equals 1, and we get outputs. The output that corresponds to x equals 1 is y equals 3. So you insert x equals 1, and you process it here, you add 2 to that number, and then you get the output here. So that's what we mean by a function. But it's very important to realize that there is one and only one value of y for each value of x. Okay. Now, a linear function is a function that's defined by this rule. F of x equals mx plus b, where m is the slope. So if the function passes through the 2 points x1, y1, x2, y2, then we can find the slope m by applying the following rule: y2 minus y1, the difference in y, over x2 minus x1, the difference on in x. So that's the slope, it's a number. And b is the y-intercept. For example, in the example that we just discussed, f of x equals x plus 2, The slope is the coefficient of x. The coefficient of x is 1, so the slope here is equal to 1. And what is the y-intercept? The y-intercept is 0 and 2. Now, mathematical modeling. By mathematical modeling, we mean that we have a word problem or real world problem, and we formulate it as an equation or more than equation sometimes, and then we solve it and interpret it and test it. This is the whole process. This includes modeling and solving the model. So modeling means to convert the real world problem to equations. Now, or equations and conditions. Now, the process is the following. We first formulate, and then we solve. We formulate equations, and then, or one equation if we can, then we solve for the variable, and then we interpret the result, and after that we can test our answer, our solution, if it's correct or not. So we start with the real world problem, and then we formulate it to a mathematical model, and then we solve that model, and then we interpret it as a solution of the real world problem. And after that we test that value and to check if it's correct or not. Now we have some important functions we usually deal with when we model problems from section 1.3. The total cost function is denoted as C of x, and this function, this is the total cost of manufacturing x units of the product. And in simples, we can write this as C of x equals some constant, some value, x plus f. This is the variable cost, and this is the fixed cost. Now the second function is the revenue function. It's denoted as R of x. So this is the total revenue realized from the sale of x units of the product, and we usually write it as R of x equals little s times x. X is number of units, s is the selling in dollars, and x is number of items or units. And the third function is the profit function. It's denoted as P of x, and it's total profit realized from manufacturing and selling x units of the product. And we usually use this formula to get the formula for the profit. So profit function is equal to revenue function minus the cost function. And here you need to distinguish between two simples. We use little p to denote the price, and we use capital letter P to denote profit. Okay, now let's take some examples, and we start with this example. A manufacturer has a monthly fixed cost. This is the fixed cost F. And a production cost of $6 of each unit. That means each X, because number of units is X. The product sells $11 per unit. So first, we want to write the cost function. The cost function is equal to the variable cost. The variable cost is $6 per unit, so that means 6X. Plus the fixed cost. The fixed cost is 42,500. And then we want to find the revenue function. The revenue function is the selling. So it's $11 per unit. So it's 11 per unit. That means 11 times X. And then profit function, this is the profit function, P of x is equal to the difference of revenue and the cost. Revenue minus the cost. Revenue is 11x minus the cost. Since we have two terms for the cost, it's better to put them in parentheses. So 6x plus 42,500. And then we simplify by inserting the negative sign here to get rid of the parentheses. So we just change the signs of these terms. And then we simplify. We have 11x minus 6x, that's 5x. So P of x, the profit, is 5x minus 42,500. Now part D, compute the profit or loss corresponding to a production level of 6,000. Production level means X. And production level of 11,000 units. So we want to compute the profit. So we have P of 6,000 first, and that is, we just plug it here into the formula of or the function of the profit. So we just plug it here, and we have 5 times 6,000 minus 42,500. And simplifying it, we get negative 12,500. This is a loss. This is loss. And we want to compute it to compute the profit when we produce 11,000 units, and that's 5 times 11,000 minus 42,500, and this gives us 12,500. Okay, now we have some important functions. They arise from different applications. The first function is called the demand function, and we will focus on linear demand. That means a linear function, because demand function can be linear, can be quadratic, or can take many different forms. But here in this section, since we are talking about linear functions, we'll focus on the linear demand. So linear demand expresses relationship between unit price and quantity. So here we have quantity X and unit price on the Y-axis. So instead of dealing with Y, XY, we deal with X and P. X is the quantity and P is the unit price. Okay, so this is our Cartesian coordinate that we deal with when we want to graph demand function. So let's take an example. We have the quantity demanded X for a certain brand of MP3 players is 100 units when the unit price is $100. So we can find an ordered pair here. This is X and this is the corresponding P. So from this we have the ordered pair 100. This is X and the corresponding price is 100 as well. So this is X1, this is P1. And the quantity demanded is 1,100 units when the unit price is $60. So we can formulate another point or find another point, which is 1,100. That gives a price of $60. So why we should find 2 points? Because you know that in order to find the equation of linear function, you need to find the slope, and in order to find the slope, we need to find to have 2 points to find that slope. If we don't know the formula for the function or the rule of the function, then we need 2 points. Okay, so the formula for P of x is mx plus b, so it should take this form. Okay, so we first find the slope. We need to find the slope. The slope is P2 minus P1. Let's call this x2 P2. So P2 minus P1 over x2 minus x1. P2 is 60 minus P1 is 100. As you can see, 60 minus 100 over 1100, that's x2 minus x1, 100. And simplifying, we get negative 0.04. So this is the slope. It's negative. That means the function will be decreasing. Okay. Now, after that, we apply the formula for slope point formula to find the equation of the linear function. So we have p minus p1. You need to remember that in general we have y minus y1 equals m times x minus x1. So instead of writing y, because the y-axis here is p, so denoted as p because it represents the price, so instead of writing y, we write p. So this is p minus p1 equals the slope times x minus x1. Now p minus p1. What is p1? p1 is 100 equals the slope negative 0.04 times x minus x1. x1 is 100 from the first point here. Good. And then we solve for p. So we first multiply, or I mean to simplify the right hand side, we have negative 0.04. We just distribute negative 0.04 into the parentheses, the expression inside the parentheses. We get negative 0.04 plus 4. We have p minus 100 on the left hand side. So in order to get rid of the 100, we add it to both sides. So that means p is equal to negative actually we have x here because we multiplied negative 0.04 by x plus 104. So this is the function, the price function. Now part B, what is the quantity demand if the unit price is 10? So this is the price. We know the price and we want to find the quantity. Quantity is x. From where we can get this? We can get this from the formula for the demand, linear demand. So it's negative p equals negative 0.04x plus 104. And then we need to plug the values. So we know that p is 10 equals negative 0.04. X is unknown because it's the quantity that we want to find, plus 104. And then we isolate x. So let's subtract 104 from both sides, and we get negative 94. And on the right hand side, negative 0.04x. And the last step is to divide by the coefficient of x. So x equals 2350 units. Okay, so that's the quantity demand if the unit price is $10. Now part C, we want to sketch the demand equation. To sketch the demand equation, we start with the horizontal axis that represents x, and we have the vertical axis that represents P, the price, unit price. And then since we want to graph this, P equals negative 0.04x plus 104, we need to find the x-intercept and y-intercept. What is the x-intercept? X-intercept can be obtained when p equals 0. I mean y equals 0 when the function is y equals y of x, or usually we deal with y and x. But here, since p represents y, we use p equals 0. So we have 0 equals negative 0.04x plus 104. And then we simplify this to solve for x. We subtract 104 from both sides. We get negative 104 equals negative 0.04x. And then we divide by the coefficient of x to get x equals, using the calculator you can get x equals 2600. So the x-intercept is 2600 and 0. Now let's find the x-intercept, the y-intercept. The y-intercept can be obtained by plugging x equals 0 into the equation. So p equals negative 0.04 times 0 plus 104. This is 0, so p equals 104. So the y-intercept is 0 and 104. So this point here. Now we connect these 2 points with a straight line. But we need to pay attention to from where the function starts and where to end. Okay, so this is p equals negative 0.04x plus 104. As you can see, since the slope is negative, slope is the coefficient of x is negative, that means it's decreasing and the function is decreasing. But we need to pay attention to the following point. X represents quantity, I mean number of items. Can number of items be negative? The answer is no. So since we don't have values of x here, because it can't be negative, we should not have any parts of the function, the corresponding values here. So we need to erase this part. So the line should start here and end at the other point here. And why we should not have this below this line? Because p, the price here, will not be negative. Okay, so this is the graph of the function. Now another related example, that's the supply or linear supply function that expresses the relationship between the unit price and the quantity supplied. So between little p and quantity supplied x. So let's take an example. The supply equation for the BWS Bluetooth wireless loudspeaker is p equals 0.025x plus 40. It's given. So the supply equation is given, where x is the quantity supplied per month and p is the unit price in dollars. We want to sketch first, the graph of this function, the supply curve. Here we don't have a curve, it's just a line because it's linear function. Okay, now we graph this, so we need to start with the coordinate system. This is x, the quantity, and this is y. But the y here, we write p instead of y, right? Because it's the relationship between unit price and quantity. Now, after writing this, we need to graph this equation, or to graph this line. So in order to graph this line, we need to find the x-intercept and the y-intercept. So let's start with x-intercept. That means p equals 0. When p equals 0 here, we have 0 equals 0.025x plus 40. And then we solve for x. So we have negative 40 equals 0.025x. And then we divide by the coefficient of x. So x equals negative number, right? This gives us negative 160. So this is negative number, and that means the number of items is negative, and that's impossible. So we don't have x-intercept. Good. So no x-intercept. So the line will not intersect the x-axis at any point. Good. Now I'm going to erase this part to find the y-intercept. Let's see if we have y-intercept. That means we plug x equals 0, so p equals 0.025 times 0 plus 40. And that means p equals 40. So the y-intercept is 0 and 40. So there is y-intercept, and the function is increasing. As you can see, the coefficient of x is positive. That means the function is increasing. So the graph looks like this. If you want to get a better graph, you usually need to find 2 points. So let's take another point. let's take the point 1000 here. So if we choose x equals 1000, then the corresponding value will be p equals 0.025 times 1000 plus 40. And then this will give me 25 plus 40, which is 65. So the corresponding value will be here. This is 1000 and 65. And then we connect them and it will continue increasing. Okay, so this is the graph of p equals 0.25x plus 40, the linear supply function. And as we described before, we cannot have any value here or part of the graph here because we don't have x values here because x cannot be negative. And we know that in this part x is positive, in this part x is negative, and in the middle x equals 0. It's possible to have x equals 0 because sometimes number of items is 0. Okay, now part B, what is the lowest price theoretically at which the supplier will make a BWS Bluetooth wireless loudspeaker available in the market? So we're asked to find the lowest price. Okay, the lowest price can be obtained when x equals 0, number of items is 0. As we can see here, it starts here. It starts here from the graph. So that happens when the price is $40 per unit. Part C, how many of these loudspeakers will the supplier make available in the market per month when the unit price is $100? So this is the unit price P, and we want to find how many. That means we want to find X, the quantities. So we only have one equation here, P equals 0.025x plus 40. So this is the supply equation. And then since P is given, P is 100 equals 0.025x plus 40, and then we solve for x. So we subtract 40, and then we get 60 equals 0.025x, and then divide by the coefficient of x. So x equals 2400 units per month.